parents. This week we are really starting with fractions. We are covering four things really this week, but then we'll be practicing all of it next week as well. Today we went over equivalent fractions, and it's a review from fourth grade, just making sure that we understand that fractions are equivalent to one another. If I have 1/2, it can be the same as 2/4 or 3/6 or 4/8 or so forth. It's a really important piece that they understand equivalent fractions because it helps them then when we start adding and subtracting fractions with unlike denominators, which I'll talk about in just a moment. And so if they can recognize equivalent fractions, that's going to be the best bet. One of the things that I talk about with my students is that when we multiply by 1, we always get the same answer. So if we do 5 times 1, we know it's 5. If we do 6 times 1, it's 6, and so forth. It's the same with fractions. It's just that the 1 looks a little bit different. So if we have 1/2 and we're wanting to find an equivalent fraction, if we multiplied by 1, it would still be 1/2. But in fractions, 1 can be the same as 2/2, 3/3, 4/4, 5/5. All of these are equivalent to 1 whole. So when we're talking about finding an equivalent fraction, and I say, okay, you need to take 1/2 and you can multiply by 2/2, that gives us 2/4, which is an equivalent fraction. And it's equivalent because this is the same as 1 whole. And so I talk a lot about this with my students about this, in fractions, 1 whole can be different. And that's how we get a different number, but we get the same value. That 1/2 is still the same as 2/4. And we also use fraction bars as well to help us to understand that because we did that, it does equal out to be the same fraction. So the 1/2 does equal the 2/4 when we do that. And so that's what we kind of talked about today, that we can find an equivalent fraction either by using our fraction bars or by multiplying by 1, as I put that in quotations, or 1 whole, depending on the fraction. So that's kind of that. Again, just kind of building the base to get to that adding and subtracting fractions with unlike denominators. Tomorrow, we are reviewing simplifying fractions. And again, simplifying fractions is just finding equivalent fractions. We are trying to find the fraction with the fewest pieces. And that's where these lovely fraction bars come back in handy. So if I have 1/2 and 2/4, we know that 1/2 is the simplest fraction because it's only 1 piece as opposed to the 2/4 here. We talk about, again, looking at those equivalent fractions and seeing, we go through and say, we talk about if we have 1/6, what's some other names for 1/6? It could be 2/12. We have fraction bars up here now, the models, so that we don't always have to use the actual bars. We can look at these models here. And then, of course, I also go over, and you can see that fancy 1 again. Another way to simplify your fractions quickly, I kind of call it a shortcut, is we now bring in the greatest common factor, which we talked about last week. And so for example, if I did 1/12 and I were to add 3/12, I would get 4/12. But 4/12 is not in its simplest form. So I would find the factors of 4 and the factors of 12, and then I would find the greatest common factor of those, which in this case, they have 4 as the greatest common factor. And then I'll take that greatest common factor and divide by 4/4, or that 1 whole, to get its equivalent fraction in its simplest form. So 4/12 divided by 4/4, or 1 whole, gives us 1/3, which is the fraction in its simplest form. And we can see that if we have 1/3, 1/3 is going to be the same. Sorry, getting all these. They're little pieces. There are fun times finding these all over the floor at the end of the day. If we have our 1/3, and we can see that that is the same as the 4/12. And again, it's the simplest form because it's only one piece as opposed to 4 pieces. So that's kind of what we talk about. And it is important to understand simplifying fractions because that moves us on to everybody's favorite, adding and subtracting fractions. And when we're adding and subtracting fractions, I always start with the models first because they need that concrete to start out with. And so if we're taking 5/8 and we're adding 1/4, when we open this up, and I'll go ahead and open up both parts here, we took our 5/8 and then this was 1/4. And if we want to add them together, we cannot do that. So kind of going back to those lovely fraction bars, trying to make sure I have enough room here. So if we have 5/8, so 1, 2, 3, 4, 5. If we have 5/8 and we want to add 1/4, I cannot add those together. They do not have the same denominator. They're not made up of the same pieces. But I can exchange my 1/4 for 2/8 because those are equivalent fractions. So I can then exchange it or replace it, take out the 1/4 and replace it with the 2/8. It's an equivalent fraction. So now I can add the 5/8 plus the 1/4 or 2/8, and that gives me 7/8 total. And so that's how I know that my answer is 7/8. The same goes for subtraction. If I had 3/4, these are my 8s. If I had 3/4 and I wanted to take away 2/3, so here's my 3/4 and I'm wanting to take away 2/3. This is what would be left right here. And I would need to find something that would put these in equivalent fractions. So I'd have to find, technically, a common denominator, which in this case would be the 12ths. So I could replace my 3/4 with 9/12. Oops, sorry. So there's my 9/12, so I can take away those because I just replaced it. And then we can see that 2/3 is the same as 8/12. So if we take those away, then there's only 1/12 left. And so basically, as you can see here, we took 3/4, which is equivalent to 9/12, 2/3, which is equivalent to 8/12, subtracted them, and I have 1/12 left over. So we spend a day really using the models and going over those and really understanding what these models mean. After we spend a day using the models, we then move on to LCD, or the least common denominator. And when we are looking at least common denominator, it's basically now saying if we took the fraction bars away, we've got to have a way to be able to solve adding and subtracting fractions with unlike denominators. And so we've got 4 steps that we do. The first step is that we have to ask ourselves, are we going to keep or change the denominator? So in this problem here, the question was 1/2 plus 1/4. and we ask, are these like or unlike fractions? And we can see they are unlike because they have different denominators. Let me go in. That's kind of hard for you to see. I apologize. There you go. So we can see, are these fractions like or unlike fractions? And they are unlike because one is a half and one is a fourth. So then our second step would be to find equivalent fractions with like denominators. So now we're bringing back that equivalent fraction. So to do that, it said this step is only necessary for unlike fractions. So on here, we could list out some fractions that are equal to 1/2. So 1/2 is the same as 2/4, 3/6, 4/8. And I can see right away that they have fourths in common. So I can change my 1/2 to 2/4. I would then add or subtract the numerators. The denominators stay the same. So I changed 1/2, keep the denominator, to 1/2 to 2/4 plus the 1/4 would give us 3/4. And then we would write our answer in simplest form. And we learned the other day that simplest form means that we want to make sure that the GCF, we want to divide by the GCF. And in this case, the GCF is 1. So therefore, the fraction is in its simplest form. If I had a problem like 2/3 and 1/5, on this one, LCD is the same as LCM. Least common denominator is the same as least common multiple. And we learned this LCM last week. So I take the two denominators, 3 and 5. I list my multiples of 3. I list my multiples of 5. And I see that my LCM is 15. So that means if I were wanting to subtract these fractions, I'd have to change my fractions to have denominators of 15 so that I can subtract them. That's when equivalent fractions come in handy. To change 2/3 into 10/15, I would have to multiply by 5/5. So 3 times 5 is 15, 2 times 5 is 10. And then down here, 5 times 3 is 15, so 1 times 3 is 3. So that's how we've come up with the 10/15, which was 2/3, and the 3/15, which is the 1/5. Now that they have the same denominator, I can subtract them. 10 minus 3 is 7, 7/15. That answer is in its simplest form because 7 is a prime number and it's not a multiple of, or 15 is not a multiple of 7. So we know it's in its simplest form. So it's kind of bringing in everything that we have worked on for 2 weeks. And then that leads us up to Friday, which I'll talk about in just a moment. The next week, we will be practicing just adding and subtracting fractions almost the whole week, Monday, Tuesday, and Wednesday. And so they will have 3 days of good practice, practicing with finding that least common denominator, finding then those equivalent fractions with the new denominator, then adding or subtracting and simplifying. So they'll have 3 full days of that to really practice it. And I do believe this is where I slow down a lot in math because I really feel the more practice they have, the better they become with it. So we slow down with the fractions. Like I said, we'll be in fractions until Thanksgiving. So we're taking the time. On Friday, the students do have a district common assessment. This is a test that the district writes. It will have basically everything we've talked about so far minus fractions. None of the fractions will be on that. So if I were to look at my fraction tab, the only thing that will be on it is prime and composite numbers. None of this other stuff will be. So prime and composite numbers will be on it. And then going back through the tabs, anything involving division will be on the test. Anything involving multiplication will be on the test. And anything involving place value with decimals will be on the test as well. So any of those things could be asked on the test. I have put up a review on the newsletter as well. It should be just right above this video. And I've also shared it with the students on Google Classroom so they can go through that. You can go through that with them, kind of see. I just put in like a sample question for each kind of thing we've gone over. Again, it's all review. It's things that they've got on their homework. It's things that they've done on their skill checks. It's just a test to see. I usually do take a formative grade on it, not a summative grade. So I take a daily grade on it, not a test grade, because it does take a full day. I mean, they will spend all day Friday, 90 minutes to work on this test of 22 problems. So I feel like if I have to give a day for it, I would like to take a grade on it. So then, of course, corrections will be allowed if they do not do well on the test. So, but this is also a great benchmark for me to see as well if I need to contact some of you to really make sure that kids are coming to tutorials and what else they need extra practice on. So it's a good benchmark for us and for you as well, just to see where they're at. So anyways, if you have any questions, this video is long. I went over quite a bit. It's fractions, I will be out the next week, the 28th through the 30th. I'll be back on Halloween. I'll be back on the 31st. And so I probably will not have a video. I'll probably just keep the same one on for next week, in which that's what they're working on for next week anyway, so it's fine. And then from there, you'll get a new video coming the next week because we'll move on to multiplying fractions. So again, if you have questions, please let me know. And be sure to check the DCA as well, DCA review as well, so you can see what is going to be on the test. And if you have any questions about that, just let me know. Thanks, and have a great week. Bye.